Hello, this is Weng. Welcome to the talk. The title of the talk is Conscious Intelligence Requires Developmental Autonomous Programming for General Purposes. I talk about introduction, Turing machines, universal Turing machines, 8 conditions, GENISAMA for consciousness, GENISAMA super universal Turing machines, and some technical details. Introduction. Consciousness must start from day one, called developmental learning. Day one means right after the birth or even before birth. Baby has a consciousness and which develops gradually, incrementally to adult consciousness. And we seek a minimal set to develop consciousness in terms of computation. And the symbolic school is not for consciousness because the symbol defined here like strokes are static and not understandable by the machine itself. And the connectionist school is not either because there are some architecture, especially the features that are handcrafted, not for consciousness, and also the pattern recognition is insufficient for consciousness. And the Turing machine is a good model and good for head scan because the Turing machine has a tape, has read-write head, and the transition with the state, and it can scan representing a kind of for limited attention, read for sensing, write for action, and state as a context, which is bad is a symbolic because the symbols on the tape and the transition table all symbolic. It's a static machine is not able to understand what's in the symbol. And no internal representation either because everything in the symbols are external to the system and the system is not able to develop internal representations. And universal Turing machines is desirable because of framework for general purpose programming, although it's a symbolic, but let's look at that, all right? And the traditional regular Turing machine is special purpose because given a task, it's a programmer who write a program for the Turing machine. Universal Turing machine is different in a sense that without knowing the task, because the task will be given from the user. The programmer for the universal Turing machine only write a program that is supposed to simulate what's on the tape. The tape has 2 parts. One is the program, another is data for the program to apply to. So because the controller can simulate any program on any data, then it's a general purpose. What is great is a general framework. It's able to allow the Turing machine to use whatever the program written in the transition 5 tuple from the programmer user who wrote a task-specific program. So that's a general purpose because the user can supply any program. And then for the developmental machine over here, where are the task program from? And where the user will write a program for general purpose computer. But what about the neural network we are talking about, machine learning? So the Turing tape becomes the real word. And the read head become the sensors like cameras, like microphone, and so on. Right head becomes effectors. What is really important here, I use red exclamation mark here, is that state is not internal, but state is effectors, right? And the developmental network is incorporating these 4 important changes. Then the real world will provide task programs. What is the minimum set for APFGP? From baby time to adolescence to adults. And let's look at the minimum set. And first talk about the GENISAMA. Minimal set is GENISAMA Universal Turing Machine. We already talked about Universal Turing Machine, but Universal Turing Machine UTM is not GENISAMA. Here, GENISAMA has 8 conditions. G for grounded in physical world, E for emergent representations, exclusively emergent. Now symbols inside. M for natural representations from sensory factors. If you have handcrafted, then human is the loop, all right? Natural in the sense that it directly gets from pictures, pixels, and muscles. I for incremental computation, no batch learning. So give example, don't do anything like ImageNet does. S for skull closed, because the brain must be closed so that it's very thin inside is automatic. Human cannot be in the loop of change the parameters or super parameters inside the skull. A for attentive, because the machine needs to pay attention to particular parts of the scene, including character scene, which has many objects. M for motivated, emotion, a special case of motivation. A for abstract, not just fitting data, right? Not just the information network for fitting data from input output, but must also abstract rules, then the system is able to have rules learned autonomously from the world. Then why GENISAMA is all necessary for consciousness? Because grounded. AlphaGo is not grounded, so must be a robot. Emergent hand program is not emergent, human is in the loop. So Symbolic School is not allowed for consciousness. Natural, the IBM Watson is not natural because symbol require a human to generate symbols in the game, right? WJPT game. Incremental ImageNet is not incremental because it's just batch data collected by many people from internet. Skull closed, all traditional neural networks were not closed. SOM, SVM, CNN, STM, because use what they would call post-selection based on the test set, right? And the humans select parameter features inside a network and also based on the task. Attentive, all traditional neural networks are not attentive in the autonomous fashion. Maybe human use the rule to do that, give example using scan and stride. Motivated, just function approximation for conventional network are not. Abstract, just function approximation are not objective either. Conscious machine, we have a paper, a conscious intelligence require autonomous programming for general purposes. It was submitted to a Science of Nature, but it was rejected. So I had to submit to AIXIV on June the 9th, 2020. Then I really like thank this conference, ICDL-EpiRob, and I add developmental into the title. So do we present today over here. Now consciousness through lifetime APFGP. APFGP is short for autonomous programming for general purposes. So essential thing is conscious learning. In other words, the machine or human or animal must be conscious while learning because it wants to choose what is important and search actively information based on the consciousness already developed that time, right? And so consciousness is not just a thing as the outcome of programming or learning, but rather also a causality, because you have a causality of conscious learning, then you can become more and more conscious. If you have a hand programming or spoon feeding learning, it will not be able to conscious. An outline of super universal Turing machine, that's a universal GENISAMA, and the end autonomous learn any Turing machine, universal Turing machine, and inside with the following two properties. When you have enough network neuron, it's error-free, because initialization takes place no matter what kind of random initial guess you have for the random weights, it will be result in the same network. If all the networks neurons are initialized, then it becomes optimal maximum likelihood. This means that there's no initial guess, all right? And will affect the final result, and they will always lead to the same network. One network is enough. And the technical detail, we talk about the framework. We have state, we have the input, and that's like final state machine, and it's controller of a Turing machine. And we have vision, and we have a campus learning, disjoint testing. We have a human handcrafted model, but it's learning for the cochlea, and the system learn while performing, in the sense listen to sound and produce sound waves. And we have a language learner which learns the English and French on the fly. And over here we have embedded representation. We have two different properties. One is the context meaning, another is language type, English, French, or neutral. Conclusion is that APFGP inside the network has a minimal set of computational mechanisms necessary for conscious systems, natural or artificial. GENISAMA universal Turing machine. Natural intelligence and AI have been unified by the theory here. Thank you very much.